Okay, well, welcome everyone to this meeting of the virtual IMS user group. Thank you for joining us. I'm Trevor Eddles. I'm CEO of iTech Limited. We're a mainframe consultancy analysis and technical authoring organization, and we're responsible for the content on the virtual IMS website, and we produce the newsletters. And if you haven't found it, we're at itech-ed.com/virtual IMS. I'm just going to let some more people into the meeting. Okay. Right, here's the agenda then for today. Let me run through that. Most of the meeting is going to be taken up with a presentation, and today our guest presenter is Radek Mrvec. He's staff software engineer, mainframe at Broadcom Software, and his talk today is entitled "Provision Your Databases in Modern Ways." A copy of the slides from this presentation will be on the website later today. And by the way, if you've missed any of our previous meetings, you can download copies of the presentations from our website. And you can also listen again to the whole session. So if there's anything there that you think, oh gosh, that's a shame I missed that, you can follow the link on our resources page to watch the whole thing. Following Radek's presentation and any questions you have for him, we'll move on to the latest IMS news and latest IMS related articles. And then I'll give you the dates and times for the next virtual meetings. So that's the plan for this meeting. I'm anticipating that it'll last probably just over an hour. Okay, let me admit a few more people. Right, anyway, as I just said, today's presentation is from Radek Mrvec. Radek joined CA Technologies, which was acquired by Broadcom in 2018. He joined them in 2012 as an associate software engineer and was assigned to the CA ACF2 security product. A year later, he was reassigned to CA Database Management Solutions for IMS for ZOS, which is an IMS tool. And nowadays, he's still working in the IMS tools team as a staff software engineer, involved in new development and sustaining work across the whole IMS tools portfolio. So, Radek, I'd like to thank you very much for being with us today. And I passed control over to you already when we tested things out. So I'll stop sharing my screen and you can share yours. One thing before we do that, Radek has asked if all questions can be held over to the very end of his presentation, and then he'll answer them all then. So, let me let some more people in. There we are. Stop sharing. There are, Radek, you can share your screen. Okay, I can see your slides. Yeah, you're not quite gone full screen on my screen yet. There.
Perfect. Great. Okay. Good afternoon, everybody. Can you hear me, Trevor? Is everything working? Great.
Yeah, all good.
Thank you. Thank you. So, welcome in my session. It's my second session in IMS Virtual Group. I am really proud to be there again, and I hope that you will enjoy this session, and at least it will give you something new and some insight to new things here. My name is Radek Mrvec, and I work for Broadcom. It's now more than 10 years when I joined Mainframe as an associate software engineer, and I think that Trevor gave the very nice presentation of myself already. So, and what this presentation is about. Okay, usually when I am working on some presentations, my big interest is that I am trying to use not common ways how to operate with a mainframe. So, and this one is from this area. Okay, we will be trying to do something which we are probably already doing somehow. We will be trying to do it a little bit differently. But stop talking about this and let's start with that presentation. First, there is some legal stuff. Actually, it is saying what you are allowed and what you are not. But now there is one part which I really like here. And this is that everything in this presentation is a subject of change, which is actually really true. Because, for example, if before 5 years ago, I couldn't imagine that I will be to use the technologies which are outside of the mainframe, and I will be able to use them on mainframe. That's really true. On the other hand, there is also a question what will be in upcoming 5 years. Okay, we don't know, but that's what I'm thinking about this term here. There is something about me. As Trevor already mentioned it. Here, if you want to somehow contact me, you can use my LinkedIn profile. The address of my profile is here. If you want to send me message, you can also use the LinkedIn. I'm quite active here. Okay, I will skip this because we already heard everything. And let's jump into the presentation. So what is it all about? Surprisingly, it is about provisioning. But question, what is provisioning? First, we need to define this term. What does it mean? Is it useful? Will it help me somehow? Do I need it? So we will try to answer this question. And first, we will define what provisioning means. After that, we will take a look at the database provisioning, and we will take a look outside the mainframe world. So we will take some simple example how database provisioning could look like not on mainframe. So for that example, I picked the Microsoft SQL Server, and I will show you how the database provisioning is performed here. After that, we will take a look at our IMS. So because IMS is also a database system, so and we will try to use or define what provisioning means for IMS. For that example, I just picked only the simple IMS database, which will be HDAM database. And we will define all the steps which are needed. And then we will also try to compare it to that Microsoft SQL Server. And the last part is that we will try to use something different than we are using so far, or what we are used to use for that provisioning. Okay, let's start with some definition. Provisioning is the process of configuring and deploying an information technology system resource either locally or in the cloud. I really like this definition because it is actually true. Because what provisioning is, so what you can provision user accounts, you can provision applications, systems, databases, and many other things which you can provision. Provision actually means that you have some idea what you need to do, and at the end there is something real. For example, I would like to provision user account. What does it mean? So that account would be based on already existing account in my system. So let's say that I already have account for Bill, and I would like to provision account for John. Okay. So, and now what I need to do, I need to perform plenty of steps. So fill some properties which will be the same as John has, and also I will need to modify the username, IDs, and emails, and that kind of stuff. And after all these steps are completed, then I will have the new user account which is prepared for use. That's provisioning. For application provisioning, it's similar. I would like to provision some application, which means that first I need to get in some installation media, install application, configure application, and run application. So in my eyes, provisioning means that from nothing, I want to achieve something usable and real. And the process between start to the end is the provisioning. Provisioning is usually also combined with the cloning. which means that I want to provision some new entity which will be based on any already existing entity. And it is our case. We will be trying to provision database which will be based on some already existing database in your system. Okay. So, and why to do that? So there are three use cases. Of course, there is many more of them, but I pick only these three because I think they are quite clear and nice and easily described for development purposes. Okay, I am developer and I would like to modify my database application to bring some new functions or features. And for developing, I will need to test it against the database, which is already in production. Okay, I have two options here. First is that I can develop and test it against production and a real database, which is not clever and smart idea. Or I can have own instance of that database, which is almost same as the production one. And this is use case for database provisioning. For testing, similar problem. So I would like to test some code changes or whatever. And again, it's not good idea to start with testing against real production database because production database is untouchable for testing and development, of course. So again, I need some database which will be almost same as the production one, and I can test all these changes against this database before I will deploy that application or code changes to my production environment. For analytics purposes, again, if you are doing some analysis and your real production database is, for example, updated every seconds or every milliseconds, so it will be really tough to run any analytics against this data. So, and I don't care about real-time data here. So maybe I'm interested in data from previous days. So, okay. So in that case, I would like to have the database which is from previous day, and it's another use case which is nice for database provisioning. So if you will be thinking about database provisioning a little bit deeper, we will meet plenty of challenges. So I picked these three, but of course there is more of them. But let's talk about these three because I think they are quite important. First one is size of database. Okay, if you are creating new database, you need to know how big database is, right? And it doesn't apply only for mainframe. It also apply for some distributed or not mainframe IT, because you need to reserve some space where your files will be stored. You need to know how much space do you need, okay? Next one is timing of provisioning refresh. That's I touched that challenge in previous slide, because for example, if you are working on some development for the database, you would like to work on the most recent version of the database. But what's the most recent version? Is it 1 hour old, 1 day old, 1 week old? So it is the question which you need to answer first. So you need to know how often you want to refresh your database. And the third one is the production data, which is a very important one because it's touching the security and more privacy here. Because your production data contain sensitive information. There are some social numbers, email address, and names and other things here. And it means that you need somehow solve this challenge because you are not allowed to use this information during your development and during your testing. And it's not a good idea to pull them anywhere else than on production system. So you can use for this one, you can use some data masking or data cleaning. I don't want to spend much time of this one. I won't be speaking about that challenge during this presentation because this challenge is for separate presentation, but it's very important thing which you need to take in account. How to solve these challenges? So it's not complicated, let's say, because one key for solving these challenges is automation. This automation, you can automate your task because what's the source of the errors? The biggest source are human errors. So, and with automation, you are solving the problem of human errors, of course, but also for automation, the idea is that you want to provision your database automatically without user involvement. User will only somehow trigger that provisioning, and actually it will insert only database name, for example, and the rest will be done automatically. So you need to, with automation, you need to solve the challenge with the database size. And also with automation, you can easily solve the challenge with a refresh of your database, because you can set your automation framework to refresh this database every day, for example. So that's a really key point, how you can solve these challenges. And the next one is communication. The important thing here is that everybody who is involved in that provisioning needs to know what's behind it. So the team is, the knowledge about the provisioning is split between different roles, because developer knows something, testers know something, analyst knows other part of the problem, and administrator also knows other part of problem. And all these people need to sit together and define that provisioning, because you don't want to forget something during that provisioning, which will be missing later. Okay, and now let's take a look at example how that provisioning could look like outside the mainframe. I pick Microsoft SQL Server Studio. Why? Because I have some little knowledge and some experience with this, but I believe that the same will apply also for Oracle or MySQL and other database systems. And that provisioning here is quite simple. First, you will back up your database and then you will restore it. And that's it. It's really easy. And how to do that? In Microsoft SQL Server, you can use PowerShell, which is really another great Microsoft tool. And since it's again from Microsoft, it already has some built-in function for Microsoft SQL Server. And for the first step, you just need this 2-line of code where you are creating some backup file of your database, and that's it. The good thing here is that these database systems are already prepared for that provisioning. It means that that backup file will also contain your database structure and also database definition, not only the data. And it's the one of biggest difference from IMS system. Next step is restoring. So you created the backup file, and now you need to restore it. Of course, you can restore it to different database system, database server, so it doesn't need to be the same one. And after this step, you will have the new database, which will be exactly the same as the original one, and it will contain also same data, only the new name will be here, new logs, and new set of files. That's for scripting way. Of course, since it's PowerShell, it's scripting language, so you can create a script and you can easily automate this script, right? So you can use your scheduler or whatever you wish like. So it's just scripts of couple of lines which can be run based on any input. Or if you like some clickable way, let's say, so you can use SQL Server Management Studio. Here on left side, there is an example how easy you can create backup for Microsoft SQL. So it's really a question of 2 or 3 clicks where you select the database and click backup, and that backup file will be created. There is one more dialog before that, but still it's really simple and quite straightforward. For the restoring, again, it's the same. It's really easy. Nothing complicated, just couple of clicks, and you will be able to restore the database from that backuped file. So it is how it looks outside the mainframe. SQL Server is offering this way. I know that I try to look at Oracle, and Oracle Server is also offering very similar approach for these tasks. And now let's talk about IMS, because we are in IMS group. So let's start with IMS now. So first, let's define what we need to do to be able to create some clone of our IMS HDUM database. Which steps are involved here? Okay, first one, we need to back up our production database. It is the same as it was in SQL Server, right? So there is no difference. After that, there are differences, because after backupping the production database, we have a data. That's fine, but we need a little bit more for IMS. We also need some IMS database structure somewhere, and that's why we need create and register new database definitions. After that, if we are using Dbrc, and we will be using Dbrc during this session, we need to register our new database in Dbrc. That's next step. Next step will be allocate datasets for new database, and that's for challenge database size. Here in this step, we need to allocate new datasets, which will be enough large to get all the data from our original database. And it's a little bit tricky part here. When we have a datasets allocated, we can finally restore our backed database to that new datasets and new database. And after that, we are ready to start our new database, and we can start to using it. So here, there are steps which are needed for creating some clone of our database. And now let's take a look a little bit deeper at every step. First step, backup production database. Okay, you have more options here. First, you can say, okay, so I can just unload my database and that's it. Yeah, that's true. But what if your database will be online? So you don't want to bring it down, create, unload, bring it up. And if you will be doing that provisioning 10 times daily, so it's not a clever idea. So we have options here, and I know that some vendor tools are offering this function. You can create unload file from image copies. If you will follow this way, it means that you won't be touching your production database at all. Because I believe that in your shops, you already have some image copy policies, which means that you are creating image copies on some regular basis or after every significant change in your database. So you can pick the most recent image copy and create a unload file from this one. So why not? So in that case, you don't need to touch your production database. So that's first thing which you need to do is back up your production database, and you can do it this way if you don't want to bring your online database down. Next step is create and register new database definition. Here, we need to distinguish between two environments, because I believe that still somebody of you is using managed ACB already, at least on your development and test systems, and somebody is still using ACB lib environment. For managed ACB environment, that create and register new database definition means that you will actually just select data from catalog which contain your database definitions here. Then you will need somehow extract the required information, and then issue just DDL statement, create database, and that's it. Create database DDL is already supporting auto create of Ims Resources, so you don't need to use that type 2 command create DB here if it's set. For ACB lib environment, it's a little bit more complicated. Because first, what you will need, if you will be creating a new database, which is based on some already existing database, you will need to get DBD source somewhere. Maybe you already have it somewhere. It will be easier for you. If not, then there exist tools which are able to decompile your compiled DBD or ACB and generate the DBD source from compiled versions. So you can also use these tools, then retrieve all the required information, generate new DBD, and then through DBDgen and ACBgen process, you can create ACB. Also, in that case, you will need to use that create DB type2 command to create the Ims resource here. And after that, you will need to switch your ACB libraries with init OLC command, and that's it. So you can see that with managed ACB, it really looks much simpler, and that's true. And that's why IBM is providing managed ACB way, because they are trying to simplify your IMS work here. And that's the one example that where you can compare same task on these two different systems. Next step is registering new database in Dbrc. For this step, we also need some information for Dbrc. We need to know how many data sets are involved and other things. And how to get them? It's easy. We can use Dbrc list commands and we get this information. So, and the process will be the same. First, we will issue list commands for Dbrc, then we will somehow extract information from an output. I'm saying somehow, but later on I will clear it. And after that, with that required information, we will issue init commands, init Dbrc command, which will be used on your target system where you want to have that new IMS database. That's for Dbrc. Allocation datasets. I mentioned it before. It's a little bit tricky here because, again, we have two ways. We can store our data in vsum datasets or osum datasets, and we need allocate datasets for this database. Of course, you can follow the standard procedure for allocation as you are using in JCL. Okay, it's possible. But for that, you will need to know some space parameters. How many cylinders do you want to allocate, or tracks, and so on. And that's what you don't know actually. So because let's assume that you know only database name and nothing more. So how to do that? So you already using itcomes, because itcomes is really very powerful utility. And itcomes is offering define cluster function or alloc function for OSUM. And it's also offering great thing, which is modeling based on already existing data sets. And in previous example, when I was talking about the Dbrc, I said that you will have the list of the involved data sets. So you know that original data sets in this time. So, and you can use them in that model or like clause. So, and use them as a for your new database data sets. In that case, if you will be use this, that new data set will be allocated with the same properties as the original data set was. Unfortunately, one thing which I found a couple of months ago is that not all properties are copied. So for example, SMS classes are not copied through model or like. And if you want to allocate also with this information with SMS classes, you will need to find another way, for example, listcat, which will give you this kind of information, and then you can use them in your itcomes statements. Okay, now we are in stage that we create ACB, we create Ims resources, we registered our new database in Dbrc, we allocated datasets, and now we are ready to reload new database from unload file which we created in the first step. For this task, you can use any of available tools which are here and just unload your new database with the data. And the last step here is we need to start our database. You can start it with type 1 or type 2 command, doesn't matter here. And after this step, the new database will be ready and will be prepared for use, and you can start to use it. And you will have the same database as the original database was, only with a different name, or it can be the same name, but yeah, it can be also a different name. It can be on different system, or it can be on the same system with a different name. Doesn't matter here. How to do that? So you have an option, you can do all these steps manually. But if I go back and if I will try to compare it, or you can try to compare it with that SQL server, so you see it's much more complicated, right? It's not only 2 steps or 4 clicks. So it's plenty of steps is involved, and we are still talking about simple HDAM database. What if I would like to provision HAL-DB database? So more steps will be involved here. So, and that's why automations comes really handy. And you can pick one of any existing automation framework. First one which came to my mind was the JCL. Of course, we are using JCL for tens of years. And I believe that you already did the similar provisioning already in JCL. You already have this kind of JCL on your machines. So it's already there, it's already working, okay? So that's one way. Other way is you can try to use Zoe, but let's say that Zoe isn't automation framework. Zoe is something different. Zoe is going much more far. You can use it. You can use Zoe CLI for that automation. You can also use Zoe API, but later on you will see that you will miss a couple of functions which, for example, Ansible is already offering. So that's where it leads me, is we can try to use Ansible. Ansible is here already for maybe more than 10 years. And Ansible is automation framework from Red Hat. And as you know, Red Hat has been acquired by IBM. So now it's part of IBM. And Ansible, main purpose of Ansible is automation. So that's why Ansible is here. And you will see later that Ansible is really used everywhere, unfortunately so far outside of the mainframe, but every automation, or most of automations are done by Ansible. Well, okay, so let's take a look a little bit deeper to Ansible. What Ansible is? Ansible is a framework, which means that it's just a set of libraries. It's not any server or something like that. It's really just a set of libraries which are installed somewhere on your laptop, for example. Why not? And these libraries are written in Python. So that's why I have here Ansible and I have a Python on the right side, which means that only what you will need to have installed on your mainframe will be Python. Ansible will be installed on your control node, let's say, which can be your laptop. Here you also need Python here. And on your mainframe, you also need to install Python. And Python, again, what is it, Python? Python is another set of libraries, nothing more. There is no server involved and so on. Of course, for Ansible, you can find that there is more things. And here I am showing the most simple Ansible architecture. But Ansible is also offering more complicated architectures. Like example, there is an Ansible Tower, for example, which is web server, which is able to control all your flows. You can manage them. You can perform some analytics against your automation and so on. We won't be talking about this here. So I pick only the most simple example which is this one. So you have an Ansible which is installed or on your laptop, for example, and then we have a couple of targets here, which can be mainframes or LPARs, whatever. So what Ansible is doing, Ansible is just consuming these two files, not only these two, it's also consuming configuration file, for example, but these two are the most important one. That inventory file is file where you are describing your targets. You are setting here IP address for your LPARs and that kind of stuff. So that's inventory file. And the playbook file is the most important one, because in playbook, you are defining what you want to do on your target. Okay, you will be saying here, okay, I want unloaded database, I want to create these data sets, okay, I want to reload this. It will be stored in that playbook. Playbook is written in YAML syntax. We will see later on a couple of examples how it looks. And YAML syntax is quite used today in almost all configuration files outside the mainframe on personal computers. And that's it. So Ansible will consume these two files, create Python payload, and through SSH, this payload will be transferred to the mainframe system, which is server here, and perform all the steps which are described in the playbook and sending response back to your Ansible master. You can also see here that we are connecting to 3 targets here, and that's another great thing on Ansible, scalability. So because you can easily execute one playbook on different targets. For example, it can be 10, 20 LPARs and only one playbook, and on all 20 LPARs will be performed the same steps. Okay, and that's it. This session isn't about Ansible because it's really a huge topic, so, and it's for another presentation. But here I am a little bit expecting that you already know what Ansible is, but this slide is just kindly a reminder how Ansible work and what is it. Okay, so let's try to automate our database provisioning with the help of Ansible. So first, we need to prepare environment. Okay, what is environment? Environment, it's really just set of variables. And in that case, it contains security variables, which could be SSH keys or other credentials and so on. Mainframe variables, which is, for example, the place where your Python is installed, okay, or that open automation utilities where it's installed and so on. It's mainframe variables, local variables. So if you are running your Ansible on your local machine, for example, and you want to store output somewhere, you need to set it. And that's for local variables. Ims variables, okay, as I mentioned, so we have only DBD name. So, and we need to know IMS ID, we need to know IMS plex, recon data sets, and that kind of stuff. And all these variables, more of them, but all these variables are describing our environment. What is it, and where all the important things are installed and reside. For that preparation, we can hit one challenge here, and it is the dynamic variables. The problem is that, as I mentioned in the beginning, we will try to provision new database, but we know only the database name here. And we will need to know more, of course, during the process. For example, we would like to know also all the datasets involved and how to get them. The answer for this is the Ansible variables. Ansible is supporting variables, which means let's go through this example. So first, we have done some simple script, simple Python script. This Python code is doing that's just writing word test to standard output, and that's it. And then we have some task. First task is just creating that script executable, let's say. Then we are executing this script and we are registering the output of this script, which is that register keyword here. The next task is that we are taking that output from this script and assigning it to Ansible variable, which is my specific var here. And the last task is that we are using that Ansible variable in another task. Okay, so it's a really great thing, because now you can imagine that you will have tasks which will query Dbrc for the list of data sets. Then you will go through the output of that command, pick all the data sets from there, and then you can call it comes, for example, and you will use that provided information from that previous Dbrc command. And that's it. And that's how you can do it with Ansible if you don't know this information in front and you cannot use them when you are writing the playbook. Okay, so you will need it in runtime. That's for dynamic variables here. Another problem could be the external tools. Ansible is currently supporting, I think, six modules for IMS already, which are provided by IBM. There is module for dbdgen, psbgen, acbgen, IMS command, dbrc commands. Some work with a catalog, but still there is no module, for example, for unloading your database, right? So it's not there. So you need some mechanism how to do that from Ansible. So you have two ways. First way is that Ansible ZOS core is offering JCL submit, which means that you will just pass some JCL to that Ansible and the JCL will be submitted on your mainframe, and that's it. But with this way, it's a little bit complicated because you will need the JCL and we don't have it. And as I probably mentioned, I don't want to touch JCL at all here. So, but Ansible ZOS core is offering one more great function, which is ZOS MVS raw. With this function, you can execute any MVS application which you like. And if you take a look at this playbook example, you can see that it is substitution of JCL, right? Because I'm specifying program name. In this case, it's our database organizer. Then I have a step lib where that DBO is stored. I have a dbdlib, database datasets, unload file, output, and input file, and that's it. The same information you will need to specify to your JCL. But the magic here is that everything what's in orange color can be replaced with Ansible variable. So it means you don't need to specify it when you are writing this playbook. You can get this information during runtime of that playbook. That playbook can already run and then get this kind of information. Okay, maybe it's not best example for that unload, but later on you will see that it's really handy. So, and actually with this example, we created the first step. We create backup of our data. Next step is that we need to create a database definition. Okay, again, we need to distinguish between ACB-lib and managed ACB's environment. And for ACB-lib, it's a little bit complicated again. As I mentioned in the beginning, so for ACLib environment, you will need to get dbd source somewhere and then get the information from it, create new dbd and so on. For that, I have only this execute dbd psb decompile utility, which exists. There already exist a couple of options to do that. So actually you will pass the compiled dbd or acb, and the output of this utility will be source of the dbd. It's just the compilation. And with the Python, you can easily extract any information from that output and use it from your next task. Here, for example, you can generate new DBD, or you can just modify that already decompiled DBD for your needs, and then run the DBD gen process, ACB gen, PSB gen, and these kind of things. And for that, you will be using Ansible modules here. So here you can see that Ansible is already providing IMS DBD gen module, which is taking source of DBD and the destination, and the same is for PSB gen, and the same is for ACB gen. So there are examples from playbook which are using that already existing IMS Ansible modules, which are available on Ansible Galaxy already. The next step is, or not next step, the same step for the managed ACB environment. And again, you can see it's much more easier here. If you have managed ACB and you are able to use DDL and you have a catalog on place, so you can use IBM utility, which is called DDL generation batch utility. The input for this utility is DBD name, and the output is DDL, which is below create database, my DB name access, and the other stuff here. So it's really, really easy. And then you can just change, for example, the name of database. And with another IBM utility, which is SQL batch utility, you can execute that created and modified DDL statement against your IMS system where you want to install your new database, and that's it. Again, you see that with managed ACB environment, it's much more easier than with ACB libraries. Create resource in IMS system. Of course, if you are using managed ACB and auto create is enabled, you don't need care about this step. If you are using the ACB lib environment or auto create is disabled, you will need to issue IMS command. It is our first IMS command in this process, provisioning process. And for that, there is already existing Ansible module, which is called IMS command, surprisingly. And only input here is that command itself. And of course, you will need to specify IMS ID where you want to execute this command, and the IMS plex name where that IMS is connected, and that's it. After execution of this command, you will get, of course, prepared that database resource on your IMS system. Registering databases in Dbrc, we already mentioned it. So first, we need to get that information from Dbrc for that original database. For that, we can use some Dbrc list command, and for whole task, we will be using another Ansible IMS module, which is called IMS Dbrc, which is already available. And with this module, you are able to execute any Dbrc command from Ansible. So after this command, we are using also the register keyword here because we are interested in that output. And then we are passing that output to another Python script, which will perform some parsing and retrieving all required information from that output. In that case, it could be the database datasets list, because we will need it later, and also we will need it for registering that new database. And that's next step, which is Dbrc init command, where we are registering our new database in that target IMS environment. Allocation of new database datasets. There are two options. The first one is that ZOS core collection is already offering ZOS datasets module, which is able to allocate for you the datasets on your mainframe. But for that, you will need some space parameters at least. and some block size and record length and so on. So, and that's the problem, because we don't know that. So, and that's why that it comes handy. Here, with the way of calling external tools, we can call it comes, pass that alloc or define cluster statements here, and we can use that like, because from previous step we have the list of all involved database datasets in the original database. So we can use them here, and that's it. So it's much easier way, because otherwise you will need somehow to get this space information, which could be tricky. But with that like, you will be able to copy them from the original data sets to the new allocated data sets. That's for allocation. Okay, and after that, there are some final touches, which means that we will need to reload your database, because everything is ready now. We have a data sets, the database is registered in Dbrc, and there is nothing what is blocking us before reloading our database. Again, for reload process, you can use that as the US MVS raw module, which can execute your tool for reloading the data to your database. And after that, we need to start our database, which we can do with the IMS command module. And again, it's a simple example of type 2 command here, which you can issue through that IMS command module. And that's it. After this step, we have a new database, which is the same as our original database, or based on the image copies which we unloaded, and the database is ready for use. The database can be on the same IMS system, the database can be on different IMS system. It depends where you will deploy it. So it's easy. Okay, and now why Ansible? So the answer is easy. Why not? The truth is that I don't want to say here that you have to rewrite all your JCL to Ansible playbooks. It's nonsense, right? So, but why to use Ansible? Okay, so far there was only JCL, and all your automation was done through JCL. But now you have options. Now you can choose if you would like to use JCL or you would like to use Ansible. Maybe you are asking why use Ansible if I am still using JCL, and there is no answer to this question, because it's option. It's how can we achieve the same results as we are achieving with the JCL, but we can achieve it with the Ansible. But of course, there exist a couple of benefits. One of them is, for example, that Ansible is currently offering tons of modules which are available through Ansible Galaxy. Ansible Galaxy is a kind of repository of all the modules for Ansible. So that's one reason, because you can find some task. For example, you want somehow involve some web services somewhere, and for that you will need to connect from your Ansible to get some external data which you would like to somehow inject to your database provisioning. Why not? So, and for that I believe that there already is plenty of solution how to achieve this. That's one thing. Other thing is that growing the US module collection. When I started looking into the Ansible, which is probably maybe more than 1 year ago, so there was only 4 or 5 collections for Z. Now, currently, there is probably 8 of them. So IBM is still adding new collections for Z. So there is already plenty of other, not only for IMS. There are also ZOS Core and ZOSMF and others, so which is still growing, and IBM is still updating. And also IBM is providing GitHub repository where is stored some example playbooks. For example, for IMS, you can find here example of playbook for IMS system provisioning. So there is already exist playbook for provisioning whole IMS system, which you can take a look and create your own based on that example. That's another benefit. The next one is easy to install and maintain. As I said in the beginning, it is just set of libraries, okay? So you will need just to install them somewhere, and from time to time, just update them, and that's it. So easy to install, easy to keep live. Great scalability, yes, sure. So you can imagine that you don't want to provision your database only on one IMS system, but maybe on multiple IMS system at once. You can easily do that because you will specify it in the inventory file. You can group your targets here, and then you can execute playbook against group of targets, not only on one target, but against group. So it's really easy, and that playbook will be executed on multiple targets here. Of course, you can use that to Ansible Town, which is another great it's web application, and here you can monitor your automation and you can analyze how is it working, and many others. And of course, the last one is that it's greatly accepted and already used in IT world. It's here for 10 years already. So, and since it is open and everybody can contribute, so you can take a look how that module collection is growing. And it is the proof that people outside of the mainframe are really using Ansible for automation, because it's really great tool for that. So that's reason why to use Ansible. And there is one more which I quite like, and it is, for example, because I know you are using JCL and you are capable to use it, but let's assume situation that you will get new hire, which will be just fresh graduate, for example, which is currently happening. Because still some young people are joining mainframe board. And now you have two options. So first one is that you can immediately start to teach them JCL and RX and all this stuff, which is good, of course. So I'm not saying don't do that. Of course, do that. But the other option is that you can also allow them to start to use something what they already know and what they are used to use. So because that YAML syntax, it will be familiar to them because they use it on daily basis, let's say. And I also believe that they will know what Ansible is and how it works, because it's quite popular these days. So that's another reason why to use Ansible. Okay, so I think that, yeah, we reach the end of the presentation. So now I'll take a look. I see one question here. At what point can we employ data masking or data pruning? What point? Okay, you will need to involve this during, before, or first. You will need to create some your backup of your database, and then it's time to clean that data. Okay, so that's the answer. So it means that in the beginning of whole process, you will need to clean the data. But that's what I said. So that problem or topic of data cleaning or data masking, it's really a huge topic. So, and it's for separate presentation. So I'm only mentioning here because it's important and we need to take it in account, of course. Yeah. So that's one question which was direct to me. And I don't know if Trevor has more.
I don't have any others. If anyone does have a question, if they can type them in, please, that would be great. Let's give people a few minutes just to do that. While we're waiting, Radek, if you can just remind us of your email address in case anyone wants to email you directly afterwards with a question.
Yeah, okay, so yeah. Can I send it to you?
Well, do you want to just type it into the chat now or something like that?
Yeah, that's true, I can.
Just send it to everyone. That would be good. Okay, brilliant.
Oh, of course, I have my LinkedIn account in that slide, so you can also use it to contact me.
Brilliant. Okay, well, I can't see any questions coming, so I'll just say thank you very much for that, Radek. That was very detailed, very interesting. So that was great. Because we're a virtual user group, we're giving you a virtual round of applause. All right, thank you very much. Okay, let's move on then. I've got a couple more slides just to show people. There we are. Let's just press on. I said I'd talk about news, but I haven't actually received any, so I don't have any to share this time. Articles and blogs. Well, I don't have very many of those either. In fact, I don't have any, but what I do have is a couple of notices that were on the IBM's IMS group. One of them is there's a Z Action, excuse me, a Z Action podcast, which is entitled "When It's Time to Migrate from IMS to DB2." If you have a look on that site, you can see that. And the other thing is that they're advertising a new course, which is called IMS Data Sharing. So you might be interested in that. So let's move on and have a look what we're doing in the future. Our next meeting is on the 13th of December. Joseph Lehman and Mahmoud Abu Zaina, they're both from IBM. They're going to be talking about distributed access to IMS via Java. So that'll be quite interesting. And then next year, we're looking ahead. On the 7th of February, we've got Scott Quillisi, who's presented a number of times before. He's now working with Precisely, and he's going to be talking about lessons learned, IMS application modernization to the cloud. So again, that'll be something worthwhile looking at. Just a reminder that we are looking for a new co-sponsor to work with BMC to sponsor this user group. So if anyone's interested, that's my email address. Don't hesitate to contact me. Moving on, we're on social media. We're on Facebook, we're on Twitter, we're on LinkedIn. We've got our YouTube channel with all the recordings of the sessions. Just a reminder that if you do tweet or anything, there's a hashtag to use, virtual IMS, if you're talking about us. All the links are on the homepage of our website. Okay, well, that's all for this meeting of the virtual IMS user group. Can I thank you all for attending? Thanks to BM Software for being our sponsor for the user group at the moment. And of course, I particularly want to thank Radek Mrvec for today's presentation. So that's all. That's it. Thank you all very much for joining the meeting. And I look forward to seeing you all again on the 13th of December. So thank you all and goodbye.